Today we are going to discuss about the traveling salesman problem using branch and bound technique. So here the idea behind the traveling salesman problem is to find the minimum route and which will starts from a vertex and then travels through each and every vertex by visiting exactly once and reaches to the starting node. That is the problem of traveling salesman. So here, three types of bounds are associated with the problem. So the first is a bound C of I. It represents the length of the path. So if it is a leaf node, C of I represents the length from the root node to the given node. Otherwise, that means I is not a leaf node, then it is the minimum cost in the state space tree. This is the first bound. And another next bound is L of I. So L of I means lower bound. L of I means lower bound of I, which is the length of the path. This is obtained from the reduced cost matrix. So a matrix is said to be reduced matrix if each and every row and column of the matrix is reduced. So for reducing the distance from the matrix, subtract a constant from the each row and each column. So this constant is selected as a minimum value of each and every row and the column. So next one is upper bound of I. That is upper bound. All of these three bounds are associated with this problem. The upper bound is the maximum possible effort to required to the tour. Required to the tour. So for this purpose, we will take one of the example, that is here one, two, three. Three nodes are there. So 1 to 1, there is no infinity. Infinity means no path. And 3, infinity, 4, 1, 8, infinity. That means here there is no self path. There is no self path. So first find the lower bound of the given matrix. So for that purpose, first you need to find the row minimum. So here the row minimum is 2. So this is the first row. This is a row minimum of first row. And second row's row minimum is 3. Third row's row minimum is 1. Same way we need to find column minimum. So first we will subtract this row minimum from the corresponding row. So here this is the matrix 1, 2, 3. So 2, which will be subtracted from this row. Infinity minus 2 becomes infinity, 4 minus 2 becomes 2, 2 minus 2 becomes 0. Same way 3 is subtracted from the second row, that is 0, infinity, 1. 1 is subtracted from the third row. This is the matrix after row reduction. Then the same way after this, apply column reduction. Apply column reduction. So here column reduction is applied by subtracting the value of minimum column value from the particular column. So here in the first column, this is 0. So infinity 0 minus 0, 0 minus 0. Here 2 is the minimum in the second column. So 2 minus 2 is 0. infinity, 7 minus 2 is 5. After that, this 0 is the minimum value. So here, while row reduction 2, 3, 1, all of these three values are subtracted from the corresponding rows. So here, total reduction is equal to 2 plus 3 plus 1 plus, after that, for first column 0 and second column 2, third column 0. So total row reduction is 2 plus 3 5, 5 plus 1 6, 6 plus 2 8. So total reduction is 8. So the lower bound of 1 is equal to 8. Lower bound of 1 is equal to 8. So here three nodes are there, so that you will find 1 to 2. First you need to find the path of 1 to 2. So find path of 1 to 2. So this is the first one. While calculating path from 1 to 2, you need to set all the entries of first row and second column to infinity. To infinity. So this is the matrix which we are going to find the path from 1 to 2. So the path from 1 to 2. So while calculating path from 1 to 2, you need to set first row to infinity as well as second column to infinity and 2 comma 1 to infinity. So by taking this matrix, we will find the path from 1 to 2. So the matrix is 1, 2, 3, 1, 2, 3. This is the matrix here. Infinity 0, 0, 0, infinity 1, 0, 5, infinity. So from this matrix, what we need is the first row. We will make it as first row to the infinity. So this is infinity, infinity, infinity. After that, second column is also infinity. Then second row of first column infinity. All the previous values are exactly you need to write. So this is the matrix. Then the same process we are going to apply row reduction here. After applying row reduction, this is the matrix. 1, 2, 3. So here there is no minimum value, and in this the minimum value is 1. That's why 1 minus 1 is equal to 0. Here 0 is the minimum value. The same way we are going to apply column reduction. 1, 2, 3, 1, 2, 3. There is no values. Okay. So the total reduction becomes 1 plus 0, that is equal to 1. Okay, 1. So here we need to calculate cost of 2. The formula for calculating cost of 2 is equal to lower bound of 1 plus a of 1 comma 2. Why? Because we need to calculate the path distance from a to 1 to 2. After that, a reduction value. After that, a reduction value. So here lower bound of 1 is equal to 8 plus a of 1 comma 2. So here this is a of 1 comma 2, that is 0. Then total reduction becomes 1. So cost of 2 is equal to 9. Cost of 2 is equal to 9. That will be the lower bound of 2. That will be the lower bound of 2. So this is the calculation of path from 1 to 2. Calculation of path from 1 to 2. So this is the path from 1 to 2. Then we need to find the path from 1 to 3. Here we are going to calculate the path from 1 to 2 and 1 to 2, 1 to 3. So among those two paths, which one is less, we will traverse through that path only. Through that path only. So path 1 comma 2. Completely calculated path 1 comma 2. Then we will move to path 1 comma 3. Path 1 comma 3 we are going to calculate. For calculating a path 1 comma 3, this is the basic matrix. So here we are going to calculate path 1 to 3. For this purpose, we will take the matrix from the previous uh, lower bound of one matrix we are going to take here. So infinity 0, 0, 0, infinity 1, 0, 5, 1, infinity. So after that, first we will make first row to the infinity, third column to infinity. After that, a of 3, 1. At the third row, first column, make it as infinity. All remaining values are appeared as same. After that, we are going to apply row reduction technique. So 1, 2, 3, 1, 2, 3. So here infinity, second row infinity, third row minimum value is 5. So here row reduction we will apply, a total row reduction is 5. After that we will apply column reduction on this matrix. This is the recursive process. So the minimum value from the first column is 0. So that 0 is deducted from each and every row, every column. Same way second column value is 0. Third infinity. So here column reduction is 0. Therefore total reduction R is equal to row reduction 5 plus column reduction 0, that becomes 5. After that you need to calculate cost of 3. So here cost of 3 is equal to, we consider the path from 1. That's why lower bound of 1 plus cost of a to 3 plus row reduction. So here lower bound is 8. A of, this is A of 1 comma 3. First row, third column will be 0 and row reduction is 5. So total 13 is there. So this is a lower bound of 3. It is considered as lower bound of 3. So here this is the uh, way of calculating lower bounds. Among these two lower bounds, we will take lower bound of 2. So lower bound of 2. Why? Because lower bound of 3 is 13, lower bound of 2 is 9. Among these two lower bounds, The minimization if the objective of this traveling salesman problem. Why? Because the route should be the less, the length should be the less. That's why we will take minimum lower bound value. So here cost of 2 is a minimum lower bound value. That's why for the next step we will consider the matrix which will be calculated while a path 1 comma 2. That is the matrix for the that matrix is taken as input for the next step. That means while calculating 2 to 3, path 2 to 3. So here the least path is, first we will traverse from 1 to 2. Why? Because 2 is selected. Then we need to calculate the path 3 to 1, sorry, 2 to 3. Why? Because only 3 nodes are there. First 1 to 2 we will traverse. Then 3 is becomes to be visited node. That's why we need to find the path from 2 to 3. The path from 2 to 3. So first we need to draw a state space tree. After that we will calculate the path. So then we need to calculate path 2 to 3. So by considering the matrix which will be in the calculation of path 1 to 2, that is the matrix we will take it as input. So this is infinity, 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 0, infinity, infinity. So after that, first we will apply 1 2 3 and 1 2 3. Second row will be the infinity, and third column also we will make it as infinity. After that, third row's second column, it will be also infinity. All other remaining values are filled as teasly. So here row reduction is, we are going to apply 1 2 3 1 2 3. So there is no change. Infinity, 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 0, infinity, infinity. Same way column reduction we are going to apply. Here also there is no change in the matrix. Infinity, 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 0, infinity, infinity. So here the total reduction becomes 0. So first we will draw the tree. 1. Lower bound of 1 is equal to 8. This is a path becomes 1 to 2's path. That's why this is 2, 3. This is 1 to 3 path. So lower bound of 1 to 3 is 13. Lower bound of 1 to 2 is 9. That's why this path becomes expanded. So we need to calculate the distance between 2 to 3. So here we are going to calculate lower bound of 3 here. So lower bound of 3, cost of 3 is equal to, what is the formula? Lower bound of 2 plus A of 2 comma 3 plus row reduction. So lower bound of 2 is 9 here. A of 2 3. Second row, third column here. Uh, this is a matrix. Second row, third column here. Uh, so we will not, we will take it as a 0, and row reduction is 0. That's why total cost is a 9. So here lower bound of uh, this one is 9. So the path is traveling salesman path. Here is 1 to 2, from 2 to 3. So here 1 to 2, by taking the first step 1 to 2, the path is 4. Then 2 to 3, that is also 4. After that, it needs to reach from 3 to 1 also. The path from 3 to 1 is 1. That's why 9 is there. So it is for the, we will take the values from the first step. So we will take the values from the first step. The problem itself gives the path from 3 to 1 is 1. So that's why I'm going to take in the problem 1 to 2, 4 is there, and 2 to 3, 4 is there, and 3 to 1, 1 is there. So the total path weight value is 9 for this problem, for this traveling salesman problem. Okay. So this is the traveling salesman problem. Thank you.